Okay, so at this point, say you've finished editing your valley bottom output, and it's where you want it. So now that we're done with the valley bottom editing, we can move on to RVD and RCA. So we'll move on to RVD next. It's pretty much follows the same outline as it did before as for the VBET project. So we'll go into the ARCAT toolbox, go to the build RVD project, and you'll notice here that it has this, you'll select a project folder the same way, and you'll select data like you did for the VBET. The inputs are different now, so we have a vegetation data set for existing, one for historic. We also have our drainage network like we did before. This one's going to be slightly different. I'll talk about that in a minute. And our edited valley bottom that we just finished, and an optional large river polygon. So we have a couple new inputs. Vegetation, if you've downloaded it, this is what it's going to look like. This is BPS and EVT. So once again, we want it clipped to our watershed boundary, and we want it in the same projection. So we got it projected there, so we're good there. Important note here though, when you're selecting these Landfire data sets as an input, you have to select the whole folder. So it's going to be looking for this entire folder. So when you do clip down the data set, make sure you save it within this folder. So as you can see here, here's what you download from Landfire. It's going to give you this raster. I clipped it, but I saved it inside this folder. Because like I said, the build RVD project looks for this whole folder, not an actual raster data set. So we'll get started with that. Select a project folder. I'm going to go back to where I saved my VBET project for this. So create a new folder here. It's the same naming protocol. Except this time we are running RVD, so we'll put RVD on the end. So we got that there. I'm going to select our existing data, existing vegetation data. So existing is EVT. So here we're going to select the whole folder. Same with historic. We'll select the whole folder. It's BPS. And once again, make sure wherever you have these things saved that there's no spaces in the path. If there's a space in the path, you need to change it to have an underscore. So the drainage network for RVD needs to be segmented. We usually do 500 meter segments. There's documentation for how to do this, but for purposes of this video, I already have it segmented at 500 meters, so I'll add that. In the valley bottom, so you've already edited one, so it's within that project folder. So we'll go to this watersheds project folder right here, analyses, output, and there's our edited valley. So that's the input for the valley bottom of this. Large river polygon, whether or not you need to use this is in the documentation as well, and how to find it. So for this purpose, I don't need it. So I am going to run the tool. For some reason it didn't like that my Landfire was open in the map, so I just took those out, and I'm going to rerun the tool here. So succeeded this time. You'll run into some weird things like that every once in a while. Just do your typical troubleshooting steps. So if we go over here into our RVD project now, our inputs, it's copied all those inputs. So it copied that entire EVT folder for the existing veg. So it has both the original dataset and the one I clipped. Same with historic. It's got the original dataset and the one that I clipped to the watershed boundary. And the network, it's pulled that in, the segmented one. It's pulled in our valley bottom from the VBET project, and if I had a large river polygon, this is where it would be stored. So we're almost good to go in running the actual RVD tool, but like we had to do in the VBET project, we need to rename this network to a standard protocol. This is also found in the Word documentation. So it's pretty much like we did for the VBET project. We're going to data source NHD, resolutions 24K, and then we're going to do the HUC ID, and then we're going to do perennial again like we did before, except this time on the end we have this 500 meters indicating that that's what it's segmented at. So now our project folder is good to go, and we are good to actually run the RVD tool. And I'm gonna exit out and get back into ARC just so we don't have any unneeded errors, just in case they happen. Okay, so I've got ARC back open. I'm gonna go to my toolbox. And I'm going to open the riparian vegetation departure tool. So you'll notice the start of this looks a lot like the VBET did. So it's basically the same name, or the same deal here. We're gonna follow the same naming protocol. So et al. Watershed name, or the Yankee Fork, and then this time we're doing RVD, so we'll put that at the end. Got the HUC ID to input, and the watershed name is the Yankee Fork again. Project folder. So this time, rather than going to VBET, we're going to go to RVD, add that. We're going to navigate within the RVD project folder to our inputs. So we're looking for existing veg. So we'll go in there, and we want the one that we clipped to the boundary, so we'll add that. Add the historic. Add our segmented stream network. And our valley bottom. Large river polygon if we had one, we don't. And then we'll just name the output. And once again, the naming protocol for this is just simply the HUC ID. And then RVD. So we'll let that run. Alright, so RVD has finished running and it succeeded. So go in here. I'll refresh this folder just in case, but let's go into analyses, output 1. It's put a intermediate in here. But that's our output. It's just the line network, and then if you want to make sure it did everything right, you can import the symbology just from the folder here, RVD ratio. Looks like it did what it was supposed to, so that is it for RVD. Move on to RCA now.